All right. Let's make sure that everything's working here. All right. Looks like we're up. So let's pull up what we're working on for this week here. I'll pull this up. Hey, thanks for the follow. Hopefully this stuff's useful to you. We are in the home lab here working on some of my stuff for the security engineering course. I need to update a fair amount of this, so that's what we're going to be doing here. Let me get this part up. So here's Unit 9 worksheet, so I got to clear all this up. There we go. Whoops. This should be... That's fine. It's annoying. Alright, better. Alright, so what are we doing? We are hanging out, talking shop about Linux, talking about systems and whatever we want to work on today. But mostly what I need to do is I'm very behind on my Linux security. I've been like non-stop since yesterday morning working. What is, I don't even know what today is. Is today Wednesday? Yeah, today's Wednesday. So working on all these different component pieces for this. And yeah. So if anybody's got any questions about Linux or any other topics like that that they want to know about, let me know. But I have a lot of stuff that I'm kind of working on. And let's go with this stuff can go away. And those things are all useful still. This can be Unit 9. And the name of this lab for this week is Certificates and Keys. Played outside of lecture time, digging deeper. And reflection questions. All right, so this is what I'm doing. Apparently I also don't have a normal chat thing open, so give me a second here. I'll give you guys the ability to see my let's put this in the background. This is a good talk to go in the background in case anybody wants to talk about that stuff too, but that won't be the main point of our talk today. All right, so announcements. That's our 9th meeting. Sign up is free. Okay, last week, and then we need to duplicate the slide, and we need to make this week. And this week is going to be our 2 major questions for the week. And then the lab for this week will be certificate and keys. Right, certificates and keys, that's what we're doing. Yeah, certificates and keys. That's fine. All right, clean up all these labs. We don't need this. And our operational activities, this first one, we won't need this. Our first one will be public and private key pairs. And we'll go to a different lab, go into the Killer Coda lab, and we're gonna make that lab. We got to build that lab real quick. Hey JBricks, how's it going? And Tungin 3213. Hey, so I had DNS3 up on stream a while back. I was noodling around on it and found something more codified solution where people write out the schema in YAML. Wonder if you had an experiment. I have not done anything with that. All of my current networking that I do is either 100% like professional stuff that I'm working on down in like in SCIFs, or when I'm teaching it, like I was just teaching in an environment, I'm using like a Percepio lab and I get dropped right into the exact, it's like the exact lab environment that I need for all my devices. So while I do suspect that that's GNS3 on the back end, I don't know 100% that it is. So no, I don't do, and even when I have time for this kind of stuff, I haven't touched like directly like networking in a lab environment in, God, I might say almost 15 years now. For sure, yeah, for sure over 12 years. But however, am I still doing it live and active? Yes. Am I still doing it with my college students? Yes. But like I haven't played with it any. I haven't, like, in fact, I was looking at, I had this lab, I had this thing that I showed my students today, which was, let me see if I can find it real quick. Let me go here real quick and say, I showed my students this, right? This is directly from Cisco. And what I was showing them was, like, we do these labs, we do this theory stuff, and then we do these lab things. But this is an actual, like, config doc for, like, a Cisco 4500 series switch, so like a 4508 or a 4513 that you may be configuring. And what I was showing them was, like, as we were going through this, it's like, yeah, so you're configuring your VLANs, right? And in your VLANs, you're using 802.1q. That's like a hard stop. That's how VLANs work. But if you're in an all Cisco environment, you can use ISL. ISL is Cisco proprietary, doesn't work with your Junipers, doesn't work with your whoever else. I was going to say Broadcom, but I think they got bought by whoever a while back, right? Anyway, so the point is all these, whoever it is, right? Whatever the switch names are, I don't even know anymore, but ISL won't work with those. So you can't use ISL encapsulation unless you're in an all Cisco network. And then we were going down here, and this was funny. I'm used to switch port mode access and switch port mode trunk. But now there's like a dynamic desirable and a dynamic auto. And I was like, look, guys, like, I'm not even familiar with this. Like, I don't, like, so I had to go read it up a little bit. And I'm like, okay, this makes sense, right? Do we want to use trunk and then switch port non-negotiate? We don't want to use DTP, which is probably some kind of dynamic trunking protocol I can assume from kind of like, concepts. But I don't do any of that kind of stuff typically. A lot of networking that we do inside of high performance compute is all flat. The only STIG standard we have to apply to is it can't be on default, which is typically VLAN 1. So we move it to 10 or 127 or whatever, whatever VLAN we want that's out of the way, and then we never think about it again. So anyway, so there's, yeah, so this is, so I was showing them where you can go to get more information. Obviously at the command line, you can always do question marks and stuff, but like, here's your options for how you're doing trunk encapsulation, right? Or do you negotiate with one of the other devices? So, yeah, and I'm very much used to switch port, mode access. Anyway, so that's all that to say, that's what I normally do with my college students and stuff like that. But I'm very, very vanilla in the networking side of things nowadays. I just do what I've been doing for 25 years now. I don't, I almost want to say like I'm an old dog not doing new tricks. Let's say here, database, let's go, and, oh, what is that one? So these are all old from the other lab. Okay, so then, so the first one was public-private key pairs, and then our next lab, and this lab is already done, certificates to secure TLS for our syslog communication. And this lab is already done, so I can throw this lab, complete the lab here, and we need to go find our lab, which is up in Killer Coda. And where's Killer Coda at over here? Let's go grab this lab. And then I still need to record this, and I still need to give the 2 discussion questions for the guys. Oh, God, I got so much stuff going on. By the way, we've got a Discord. You guys are always welcome down in our Discord. And I was going to show you real quick that in our Discord, what's going on here? In our Discord, There are a bunch of events. In fact, there's an event going right now. All you ever have to do on Discord is go to events. They're working on the Linux admin course, which is the other course. I'm working right now on the Linux security engineering course. They're doing the admin course study group, so they're going right now. I think they started over an hour ago, but I mean they're still down in there. I think there's still a few people down there. Then there's security engineering group. So there's a bunch of people doing study groups and stuff. Those are all free. You guys can just stop in any of those if you want. And then we have the Bash study group that's on Saturdays. And then we have our 2 official meetings, which are the Linux sysadmin course and the Linux security engineering course. They're starting week 10 or unit 10 this week. The Linux sysadmin course we've run before, so that one's all ready and done. Excuse me, the security engineering course is on its last week this week. However, I gave the Unit 9 stuff, but I haven't recorded Unit 9 yet. So the first 8 units are all recorded up on YouTube for people that want it. Then there's the writer's room for people that are working on the books. The books are free, and they generate them out of GitHub. It's actually a pretty cool little process that they use for that. So if anybody wants to get involved with that, there's also a Git study group. So my point is there's all kinds of things for you guys to go work on and get into if you want to get involved with this. We have almost 4,000 members, and we don't charge you anything to hang out. It's just hanging out. All right, let's go find my lab that I wrote for this, for our syslog. It's under Linux labs. We're up to 35 of them now. And it should be right here next to my other rsyslog stuff. So here's our syslog. Now here's our syslog with TLS. So using transport layer security inside of our syslog. All right. And then we're going to do this. When you finish the lab, you can ensure that. Okay, when you finish the lab, review the following items. All right. Also, better do that. So that's good. What else? What else? Okay, so now we need to make our lab. We also need to make our discussion questions, and I also have an Excalidraw hanging around here somewhere. So let's just pull this up real quick. And the Excalidraw kind of deals with exactly what we're talking about. By the way, this is funny. This is the same thing. I drew this up for my college students last night. Is this in my? Yeah. This is in my other one, but this is the simple communication model, right? This is for any of us doing any type of networking or any type of systems work. This is the simple communication model. There is no simpler communication model that exists that works. There are more simple ones that don't work, but these are the 5 pieces. These 5 components must exist for communication to occur. Arguably, only 4 of them must exist, but since we can't eliminate the 5th one, in practical application, the 5th one always exists, noise, right? And I'm not necessarily teaching you guys about that stuff right now, but when I do my final for this course, when I pull everything together, this is going to be a thing that we're going to kind of work on. Twisted Seed over on the Twitch side, how's it going? I'm just working through, I'm cleaning stuff up. I should have had this ready by Saturday for the group, but I just didn't. So I'm kind of working through all the stuff that we talked about. Also, did I draw, I don't know if I do any of this other stuff, so I might just be writing this from scratch right here, which I believe is my next thing to do. So, all right, yeah, this will be my next thing, which will be, we're going to call this is going to be a security lab. So it's going to be up in the 211s or in the 200s. So it'll be a 212 probably. And I got to figure out what assets I want to give. We won't make any assets. We'll start this one from scratch. So let me pull these back up. And we're going to make a lab that does these things here. These were the commands that I actually ran when we were all hanging out and working on this stuff. So this is what we'll do. And then also I need to draw, I know I'm kind of all over the place because I didn't really have a good plan about what I was doing. Man, did I just... It's funny, I drew everything the other day and then I didn't save it because it was just part of the discussion. So we'll just move over here and we'll just make a new little section, and this will be our drawing. Yeah. So let's draw real quick. Let's see if I can make my drawing nice enough to be worth something here. So we're gonna go here, right? We're gonna draw a line down. I guess I don't need my drawing tool for that. Hold on. Control C, Control V, move over here, and then we're gonna go here, and we're gonna say plain text, ciphertext. So when we're doing this, we got plain text, ciphertext, and then in here we're gonna do. Let's just draw two of these. So this will be here, and then we'll put another one over here. And then, whoops, we'll distinguish between them like this. Here's one. Plain text. Might just redraw this. And this one will be symmetric keying. Or symmetric. We could say, yeah, that's fine. Yeah, that's fine. Symmetric. And then we'll go ahead and copy this. If I can grab on the screen the right way. Go over here. Get rid of all this crap that I just copied, I know. And then we're going to make this asymmetric keying. Or asymmetric cryptography, or whatever you want to call it, right? So in symmetric keying, right, when we go from plain text to ciphertext, we have to use the same key on both sides. So we've got same key. Yeah. Right, same key on both sides right here. Boom. And then we're plain text over here, ciphertext over here, same key on both sides. So if I have something like hello, right? And then in here, it might be, you know, something like that. And over here, it's going to be hello again, right? That's how we do ciphertext. This is the idea of an encrypted tunnel over some kind of non-encrypted, right? So this is the idea of like an encrypted tunnel right here, where this becomes, as it passes through right here, this becomes that, and then it comes back through here with that, with a reversal of the same process. And it's like a decoder ring. It's the same key on both sides, right? This is the general process of what we're doing. Oh, Quartz said we had it cracking up with Discord 5 Linux commands. Man, you guys have no like the calm exterior of me and the underlying just it's not good for like people on LinkedIn that are like, I'm on day 3 of my 100-day coding challenge. Watch me talk about how to create a function in Python or something. You're like, oh my fucking God, man. Like, tell us when you're fucking done. Tell us, like, I don't know, man. Like, I get that LinkedIn is supposed to be, like, social media or whatever, but it's like, geez, man. Like, tell us when you're done. Like tell us when you have... I don't know. I'm going to get too cynical here. But, like, tell us when you've got something that's worth talking about. Jesus fucking... Like, man. It is annoying. People just, you know... Never done anything in there. All right, asymmetric keying is a public key on one side, and this is a related private key on the other side. And it's funny, when you encrypt something with a public key, you cannot decrypt it with the same public key. You need now the private key to decrypt that message. I don't know if you guys knew that. There's no way to go back into the tunnel. This is a one-way pass. This right here is a one-way pass into this tunnel. Over here, I should draw this out. In this side, this arrow technically could have. This could also be reversed back this way. He can decrypt the message himself if he needed to. There's nothing stopping him from decrypting himself. Anyway, so yeah, if anybody's wondering like what the heck I was just talking about, in our Discord, like we were talking about people who, hey, learn these 37 Linux commands you must know. And it's like, you don't need a bunch of Linux commands. You need to know like how to do some Linux, right? Like you need to understand the process of, anyways, I don't care. I don't care, literally. But the point is, you can decrypt your message here. This tunnel can go either direction, but over here, things that are signed by or encrypted rather by a public key can't be decrypted back by that public key. It doesn't work like that. It's a one way. And then the plain text, to get it back to plain text over here, you need the related private key to either decrypt it. And now this is an asymmetric keying. This is one thing that happens with private and public keys. The other thing we can do is we can also use them to do what we do. Like it's a validation of who somebody is. It's a trust by a certificate authority. We trust certificate authority. It gives us a public key. We can send a message that only they would be able to decrypt with their private version of the key that they also got from that certificate authority. They should never share that with anybody. I see, man, another one of those ones, like people on LinkedIn that are just like sharing all this stuff. The one day the site, I'm not even going to mention them because it's not worth mentioning, but they said that the server sends its private certificate, and I'm like, what? Like the private one never leaves, right? You always keep the private one yourself. But it's another one of these, just everybody just sending bullshit all over the internet and nobody even knows what they're talking about, and it's absolutely maddening. But what can you do, right? Like, just keep working on stuff, I guess. All right, so we've got all this. Hey, Robodom, how's it going? We are not working too hard today. I'm just kind of hanging out in the lab, or I'm putting stuff together for our talk. But at the end of the day, this is kind of what we're doing. So let me just grab these real quick. This will be what we call good enough for government work, right? Good enough for what everybody's paying for, which is nothing. I don't charge anybody for any of this stuff. So symmetric keying as a general thing kind of looks like this. And then, so overview, we got to fix the overview. We'll leave it. And then, oh wow. All right, this was configuration management stuff. So let's just say, that looks fine. Right. And then we'll go down here and we'll do asymmetric keying. And we'll take a new screenshot once we get back in over here. Get over to here. That's good enough for what I want. All right. I gotta finish this stuff, so that's why we're working on it here while we're hanging out. All right, that's fine. So, we talked a lot about. So overview for this week. All the things that we're doing is got so encryption. We've got right public versus private keys. This will be and then the other things that we kind of did were how they sign and validate trust. There we go. All right, X509 starts on how they sign and validate trust. What other things were from this week? We talked on Saturday about all these things. I haven't codified it down into a fucking, haven't put it all down in here yet. Symmetric, asymmetric, X509 starts on how they sign and validate trust. TLS operations, versions. So versions, non-repudiation. So I guess that's technically kind of under. Let's put that under TLS operations, what non-repudiation is. So it's the idea that I can only be talking to you. TLS also has I guess you would call it protections against replay. It's non-replayability of communication. That's fine for now. Yeah. Okay. Encryption. Yeah, that's good enough for what we're doing and what we're working on here. So, Robodyne was pretty good. Yeah. I checked on some of my old Army buddies, made sure they weren't tasting all their. I can't say that. I'll get in trouble. Right? I'll get one of those flags on Twitch. But yeah, I did make sure all my old Army buddies were okay and stuff. Yeah, because infantry guys, I guess, take it a little harder or something like that on Memorial Day. But I don't know. I'm not one of the. I'm not overly. I don't know how to put that, but I'm not overly sentimental about things like that. I mean, I pour one out for the homies and I set a table place for them, but I don't sit around and like I don't know, let it get, as we call it sometimes, getting all in my feels about it and that kind of stuff. I guess to put it that way, as some of my buddies joke around, we just white knuckle it until we can't hang on anymore. But I mean, it's not like I sit around and worry about that stuff. So, I mean, it affects everybody, but it affects everybody differently, obviously. What did we do the week before? I got to go look at the last week. So hold on, we got to pop up the prologue unit 9. I got to go into unit 8 real quick. And I got to go pull up the discussion from Unit 8, which is what this one comes from. And what was this week? Wait, so Unit 8... No, hold on, I'm in the wrong one. What am I doing here? Don't save. This is... Alright, I don't know what's going on anymore, guys. Yeah, this is Unit 8. What's going on here? Just lost all that fucking work I did, guys. Fucking A, man. That pisses me off. Alright, this week was... Okay, so we did... That week was monitoring. I think that's the week before. I don't think I updated. Yeah, I didn't update what our discussions were for that week. So that's my fault. All right, well, now I get to go redo that whole worksheet again. So that's wonderful. Yeah, didn't take any of those changes. All right, fuck it, I ain't doing that again. All right, we'll go do something else fun. We'll go build our lab out. Don't worry about that. Let's go build our lab. That's fine. This will be easier anyways. Let's we'll just go ahead and copy this one. Screw it. We'll use this. Paste a new one. And then we got to rename it. This is going to be called SH keys and SH keys and let's go public private keys with SSH. There we go. That's better. All right, that's what we'll do. We don't have any special assets for this one. Let's go look at the index.json and let's change this to, we'll do similar name to this. So public and private keys with SSH, sure. The first part of this will be key pairs, and this will be testing there we go. All right, so those will be the two things we do, and then we'll come over here, go to intro, Prolog security, perfect. We don't have anything special to run in the foreground or anything that we're adding for this. And then when we're done, we're going to say, look at you, learning Linux security. You created key pairs and validated that they were related to each other cryptographically. You regenerated a lost public key. Can't do that the other way. You can't create a private key from a public key, but you can always generate a public key from a private key. You then pushed the key over and validated. Pushed the key over to another system and validated that you could get access. That's good. That's what we'll do in the lab. All right, that's what we'll do in this lab. So we get to the end. Now we go work back. We're going to generate and test some SSH key pairs. And we're going to test and validate some things. So let's go over here. We'll move this generally out of the way. These are my notes from the other day. Actually, I grabbed these from the presentation as we were doing the presentation. This was me throwing these all in OneNote or Notepad++. And then what we need to do is pull this up. Guess we can, yeah, we'll use this killer code here. Drop it over here. That legitimately just ruined my day. The fact that I have to do all that Unit 9 stuff all over again. Because 8 popped up on the other, that's super annoying that it did that. And then I was like, oh, this is 9, why did it come up as 8? And I closed it, and I lost all that work. Super fucking annoying. All right, anyways, so let's go here. Let's go pop in a general, we'll just go in one of our Linux labs. It doesn't really matter where we go. And we're going to add these here as our steps. In fact, I'm going to pull these out because you guys you don't need those right now. I'll move those out of the way. So they're out of the way over here. And then we're just going to keep going. Let me see, make sure I'm not missing anything too much. Yeah, nothing going on over there. All right, so text, we're going to say, so for this lab, let's just say that, man, I don't remember where I put any of that stuff. Anyways, your team is trying to better adhere to 800-57. So NIST 800-57 is key management. So if I go NIST 800-57 right here, this is key management. So your team is trying to, and actually I'm going to tell you guys something that has actually happened to me recently in my career. Here's the NIST standard if you guys need it. Hey, Practical, how's it going? I haven't been streaming in a while, but I hopped on because, let's see, I got all my work done for the day. I got all my college teaching done for the day. And then the wife's out of town, or not out of town, she's out for the night for another couple of hours at a church thing. So when she gets back, I'll hang out with her. But for now, I'm just hanging out with you guys. So the NIST special recommendations for key management deals with this problem here. So your team is trying to better to adhere to NIST 800-57. There was recently, let's say recently, a key was found for root that had not been changed for over 15 years. That is a true thing that I've had happen in a company that I've worked for. There was a root key sitting there that had not been changed for 15 years. Now, you might say, well, Scott, were you guys changing root's password every time? Sure, but if you have the key, you bypass the password, right? In most systems, you just go in with the key. So somebody that was root admin at any time could have copied that key off. You have literally no way to track that in Linux. So this is a thing I actually have run into, right? This is a real thing that happens. So the recommendations for key management are how we rotate keys. And a lot of times we use Ansible or other automation tools to deal with our ways of rotating things. So this is a place to start for an organization. It's not the only place to start, right? But this is a place to look at how cryptography works and how cryptographic keys play into us not having to put passwords everywhere, right? It's one of these ideas that, like, if you were always losing your keys, that would start to be a real problem if people like knew where you lived and like stuff like that. So like obviously we don't want to just leave our stuff like this. So anyways, here's some information about what's going on with the systems, and they actually have a pretty good little warm up here to like security. They have confidentiality, data integrity, authentication. We can prove somebody is who they say they are if they've got the private key to go with any public key, right? Authorization, we can then allow them to come in as that user and get certain permissions. Non-repudiation, right? It's a term associated with only the person that has the private key. They can prove that it was them and not somebody else, right? So this is a really good kind of little write-up to start with how this cryptography type stuff works. But anyway, so your team's over there trying to better adhere to NIST 800, and it's special publication, so SP 800-57. And I'll probably drop that link in right here as well. So I should be able to do something like this, and that should drop it directly in as that link, right? And I should be able to control click and go to there. Okay, cool. Recently a key was found, the root is over here. So you have decided to learn more about how key management works in Linux and generate. So here's your tasks. 1, generate some keys, key pairs, and look at them from a system and a so from a system and a cryptography view. All right, that's one thing you're going to do. Next one is verify that the keys are cryptographically similar. Regenerate a key, a public key that has been lost, or a private key that you have kept protected. That's a good start. That's a good start for everything. Let's come down here, pull all this out. Don't need any of that part of the lab anymore. So now we start writing our lab. So just here on a system, I might say, so here's our lab environment. And we are just down in one of my labs. If anybody wants to hop on and do these commands with me, you could. Here's the lab that I'm in, but the lab that I'm in is not relevant to what I'm doing right now, right? We're just using that lab environment, right? So who am I, right? I'm root. I'm in the root home directory, right? I know all those things. And I'm going to make a directory for keys. CD to root keys. Now I'm gonna do those, and I always do these very, very explicitly over here, and I use what's called absolute pathing, right? So I'm gonna say make dir root keys, and then we're gonna copy that same thing, and then CD to root keys. So make a directory for your testing. Go into that directory, right? So we'll do those things. And then in here, I'm going to generate some keys. Some keys and key pairs, ensuring that you do not overwrite your keys in root.sh, right? So how are we going to generate a key? Well, we're just going to do a simple SSH keygen and SSH keygen, and we're going to follow the prompts. So follow the prompts and make a key prolog, a key pair prolog. So follow the prompts and do that. So SSH keygen, right? And then we're going to just make a key pair called prolog. That's it. No passphrase. No passphrase. Boom. So this may be right here. Follow prompts, make a key pair. And in here, it might be something like this. That should render a little better on the thing. All right. So it's going to generate that key. And then here's the thing is, what is the default that it's using? Like, is it using RSA? Is it using any of these other types of keys that it could be making? Well, we're going to figure that out here in a minute. We've generated the key. Now we can go look at the key from like a cryptographic standpoint. So let's go look at that. So actually, there's two ways I want you to look at the key. So inspect the key for permissions or inspect the what was generated for permissions and from a system, from Linux system perspective. ls-l in that directory, right? So if I just clear the screen, ls-l in here, I should see the private version of my key and the public version of my key, right? I mean, that makes sense. So can you tell the public from the private version of the key? Yes, because the private version doesn't have an extension and the public version does. And what are the permissions of the two keys? So the private key is only readable, so it is a 600 permission, is only readable by the root owner, readable and writable, but readable by the root owner of the key of that file. But the public version is 644, so it's readable by anybody in the world. Anybody in the world that you would want to share this to can read this key, right? Without changing any permissions, they can just read it. So that lets you know that the public key can be shared far and wide. The private key you always keep close. You never let the private key out, right? So we've got that for our lab, right? And then we want to maybe test some things about this key, right? So now the next thing is test the keys for cryptographic similarity, right? And that's going to be, this command here. We're going to say SSH keygen, and then we can go and test what's going on with the key, -y, -e, and -f, and then the key, so pro lug, right? Too many of them. -y, -e, -f, pro lug, like that, and it'll tell us information about this key that was generated. It's 256-bit, ED 25519, as opposed to RSA. So sometime recently they've moved over to using the ED 25519 instead of RSA. So good. So that's the type of key we have. And that is going to be exactly the same thing we see from pub. There's the public key, and you can see that they have the exact same fingerprint. So do you see that they have the exact same fingerprint? Let's make this just slightly smaller. Yeah, that's fine. I don't think that key will fit unless I maybe make it even just a little smaller. It might just be a carriage return there, so it might not work even if I do make it. That's fine. Not really super worried about it. All right, so that's the same. So those keys are similar, and then go ahead, delete the public key and regenerate it from the private key. So this will be rm-rf prolog.pub, and then validate. We're gonna be absolute again. Root keys, right? Yeah, root keys. Okay, good. So root keys, CD in there, all the way good. Okay. Verify that we don't see that key anymore. So, where is that? So, all right. So validate that you do not see the key. Generate a new public key from the private one. And I gotta remember how to do that. Right? No key again. And I'm trying to remember this. That shouldn't be -LF. Let's try that. I'm looking at my notes over here. On Prolog here. Ah, so that's actually the one. LEF. Oh, that gives the, yeah, everything. We might also just do, oops. Get that out of there. That's the main one that I care about right there. Okay. And then we generate our new one. I gotta remember how to do this. Hmm. Yeah, we could generate a whole bunch of other things too if we wanted. But I want to... I don't remember the command I used. Damn it. Alright, I'm going to have to look up the command. Because I have lost my commands to the annals of time. Let's see if I can find it real quick. Let's see if Server Fault will help us out. Server Fault wants to make sure I'm a human. That's no great. Get out of here, Server Fault. I just want to see, because I don't remember how to do this. I had this the other day, but... Was it that? So we only have this now. Ah, keygen. Dash Y should... For that one. Oh, yeah, okay. That was my bad. Should be dash F. And then Y. Okay. There we go. Then we just throw that into the public key. Yeah. So we can generate it like that if we wanted to. That's not how I did it though. I'm pretty sure there's another option to build that key like that. Oh, that's weird. There it is. All right, I don't know what's going on with me. Prolog.pub. Anyways. I don't remember that being the exact same thing that I did though. But that should at least have that. Huh. That'll work for now. So, if that works, and where's our command at? This one. And then we should be able to do our steps again from earlier to make sure that they are similar, right? So, pub, and then we should be able to do that same thing for the Prolog and see that it's there. And then also we should just be able to do the shorter version of that, which is the LF. And then we should be able to also do the .pub and see that they're cryptographically similar. Okay, so the keys are similar. It's actually interesting watching this. So I think I did this the other day in here. Where's all my keys? How did I regenerate that? I know I definitely regenerated that in here. Because then I deleted them all. Alright. Alright, that's good enough. So Let's try this then. Let's say then that we wanted to test that this key pair worked for us to communicate across between these two systems, right? So we can say there's an easier way to do this than it used to be. So you can now test the keys between two systems. So we are going to SSH SSH. God, where the hell's my hands? Copy ID of this prolug over to, I think we need a -I prolug, right? That sounds right. Over to, we'll just say node 01. So, cannot resolve host name. Resolve host name. Oh, it's because I jumped. Well, this is my fault. I jumped into a lab that only has one system, so I can't jump into another system on this one. All right. Well, then I gotta go into a different lab. Let's go do this on a different lab real quick. Let's go find one that for sure has 2 boxes. I don't know. Oh. Doesn't really matter which labs we use. Two-node environment, fine. Don't care. Don't care about that stuff. There we go. Okay. Got all that. Let's SSH keygen our prolug. No passphrase. See them both. Good. Let's SSH-I prolug over to node 01. And, well, for that first one, it's going to need either a passphrase or, I think, let me think about this. I might be able to, if I can still, because I don't want to use that, use a different identity file. I want to use a different So interesting. We should be able to connect. See, when I'm trying to use that identity file, it's not on the other system yet, and I don't have the root password for that. So there's another way to do this, right? I can just SSH node 01, right? And I can just do a user add -m prolug, and then pass wd prolug, and the password for him will be like 1234, right? Something super simple. Come back over here, and then now when we copy that over, we can go to that user at node 01, and now we know his password. So it's 1234, and then that should. Oh, well, I didn't want to do that. Exit. I wanted to SSH copy ID. Oh, did I really just? Oh, damn, I'm dumb. Now it'll pop that key over. And then now if I SSH over there with just that, right, it'll drop me in there. cd2.sh, and then in here, they don't let me do that. That'll be the same thing. It's the same thing right there between them. Yep. All right. So, test the keys between two systems. Create a user prolog on node 01. This will be, and then you're just going to SSH node 01. Let's just SSH over there, that's fine. User add -m, prolog. So, create a user prolog. Exit. Exit back to control plane. Exit. Okay. Now we need to go to, let's think about this. We're going to do our SSH copy ID. Copy over your generated key. Okay. Then enter the password you used earlier for prolog. Right? And then test your connection, which will just be SSH. Actually, the whole thing. And then to verify that the key is the one being used with -VUV. Actually, might only you can really just use one V. So if you guys have never seen that, SSH 1V, and you'll see that you connected over, but the key, the public key that was being offered, the server's going to accept that key. Right. Do you see? Being accepted in the verbose debug. And you should see that, right? Then when you're done with that, you're ready to move on, I would say, to the next part of the lab. We'll test that lab here in a bit. But now we come to the next part, and then we got to do the actually, what did I say we were doing here? Index. Oh. So that, yeah, sorry. So I did all in one. So that was the end of the lab right there. So we can come here. Let's go here. That makes it easier. Now we got both of them done. What's our verify for this one? Nope. Been true. And the verification for this one will be, I don't know. As long as you got Prolog in there. And then this one will be, yeah, that's fine. That's fine. All right. So, what are we doing? We are testing that communication. And that all worked. Let me see the disconnect. Okay. So, got all that. Got the verification good. The finish looks good. All right. So then this part of that lab is ready to test. And we need to do one other thing. We need to take this name right here, 212, and we need to add it to our structure JSON. Because what happens is, as we build these labs out, we can put them wherever we want. But we have to ensure that we build the order, right? We're the ones that build the order here. So it's 212. Whoops, 212. And then his value is public, private with SSH. All right. So come over here and say new lab finished for unit 9. Update. Commit up our changes. And then we're gonna go actually look at the killer coda. It's gonna bug me so much that I gotta pull all that, redo all that lab, all that fucking. Probably my least favorite thing is building out and PowerPoints and crap. So and there's a lot of thinking involved, but not a lot of technical stuff. All right. Go check this lab. We're going to test our lab, and then we'll take the 2 labs, put them into the lab for the week, so then our lab stuff will be done. I got to write up the 2 discussion questions, and then those will be done. And with the discussion questions in the lab, then I can go finish the presentation, which, again, I guess got to go fix all that crap again. Oh, that's what I get. That's what I get. All right, let's go look at our public-private keys. And we'll come over here, excuse me, in case we got any questions or anything we got to fix live, we'll fix it over here. Make that a little bigger. Team is trying to better adhere to NIST SP 800-57 here. Boom. Let's say that a little better, which can be reviewed here. Here, right? Period. Right. Recently, a key was found in your environment that had been changed over 7 years. All right, good. You've decided to learn a little more about key management, generate some key pairs, and look at them in system from a system and a cryptography view. Verify that that the keys are cryptographically similar. Regenerate a public key that has been lost for a private key that you have kept protected. Okay. And we don't care if a public key is ever leaked. It doesn't matter. You go to the town square and throw public keys everywhere. Nobody cares. Private keys are the ones that have to be kept safe, right? All right, so here's our solution. CD, make directory, keygen. Make sure that we save this to Prolog. Boom. Empty, no passphrase. Good. All right. ls-l, we see the two created. Good. We go look at the first one. There's some information about it. Look at the second one. They are cryptographically similar. We can tell by the fingerprint. Okay. We'll remove the Prolog pub one and look to see that it's gone, and then we'll generate a new one from that. And then we can, if we wanted to, verify that they're the same again. And they are. Good. Go to our second part of the lab. Oh, I need to fix that at the top. All right, let's go fix that. You have verified the basics of your key operation, but now you want to test them between two machines. Create a user to push the key to and test with. Push the key and validate that it works for allowing access to the user. Yeah, that's fine. System. Okay. Control S. All right. Let's at least make sure our solution's good. SSH to node 01. User add Prolog. Make a password for him. 1234. 1234. Exit back. Copy over. 1234. And then make sure that we can connect over there as that user. Right? Then we need to put in an exit. And then we can use this. And an exit. Whoops. Okay. And let's go ahead and just drop this here. So, SSH Prolog, test your connection. And then verify that the create key is. Okay. Updated lab. Updated lab for more testing. Boom. There we go. All right. So, next thing I gotta do, gotta come back out here, wait for my hook. It'll call. We'll see it call again. Over here in Creator. In this one, we'll see that it was updated today. Yep. And then we'll see that the Linux lab is there. And I can close that. I can close that. Come back over here. And we test it again, right? That's what we do. We test our stuff with a certain rigor. If anybody wants to test this with me or find anything, there you go. Also, some of you guys, when I post these up in the Discord, you can do pull requests against the repository, right? This is all a open repo. If you guys ever need to go check your answers or anything, you can see them in the system. All right, NIST is better adhere. Your team is trying to adhere to NIST 800-57, which can be reviewed here. Recently, comma, should have a comma there. A key was found on the root had not been changed for over 15 years. You decided to learn more about how key management works in Linux. Okay. So. Make directory root keys, SSH key, make it Prolog, local. Okay. Make sure that we see the two keys. We do. 600, 644. Good. Check to make sure that they're similar. They are. They have the same, what we would call a fingerprint, right? And then we remove the public one and we regenerate it. And then if we do an ls-l again, we would see that it's back to being the correct information. All right. Now you verified the basics of your key operation. You want to test them between two machines. We would go to node 01, make a user, give them a password, 1234, very secure, 1234, very secure. And then we'll exit back out. We'll copy that over, 1234. And then we're going to jump into that user. And then what I really should do Yeah, let's add this. Let's add this in because this is important. So verify the key is the one being used. So before we exit, so when we first test our connection, look at where the key was pushed to in the Prolog user home directory. So we're going to cd to home prolog .ssh, right? We are going to then in there. You guys might wonder too, why do I always break the commands up? Can't we send in a bunch of commands? Sometimes the commands get caught up getting sent in, and it's better to just have them all separate. Just send in your one-liners. ls-l. What permissions do you see on the file? What is the name? What's the name of the file in there? And what is the permission that you see on the file, right? Also, before you even go in there, should have. Oh, I didn't copy that whole thing. So we're going to ls-ld that directory, right? Let's do that real quick so you guys can see it. ls-ld on home prolog .ssh. What permissions do you see? It's always 700 for that type of directory, right? And if it's not 700, your system's not going to use it. Your SSHD is not going to use it. So what is the permissions? What is the permission that is set on the .sh directory? Okay, and the owner is prolog, right? I think you guys know that. All right, so what is the title? What is the file you see in there? Okay, we see that file. Cat authorize keys. So let's come down here. Cat authorize keys. Can you? What was pushed? So what was pushed into authorized keys? Is that not just the public key that was pushed over into authorized keys? And the answer is that's yes. Just the public key got pushed over. Pushed into authorized keys. What is the name of the file in there? What is the permission you see on that file? And it's the permission is 600, right? Same thing. CD in there, ls-l. Yeah, that'll all work. Okay. Good enough for government work. Updated. Key management. All right. Last thing we would do, exit back out, push that over, and then exit back out again and see all that work. All right. Look at you learning Linux security. You create, let's make that space there. I want to clean that up a little bit. So the finish. Create key pairs and validate that they were related to each other cryptographically. You regenerate lost public key from private key. You then push the key over to another system, validate that you could get access. All right. That's good. All right. It's pretty good for that part, I guess. So that'll be its own lab. By the way, now I need to go put that in that file, and that's been updated. So good, I can get that out of the way. Get that out of the way. And let me go grab that other lab now. All right. So, public-private key pairs. Boom. And now I can ask additional questions about that, or yeah, that should be good. I'm just gonna write it like the other one. Complete the lab here. So now you got the private public key pairs. And then what is So what is the significance of the permission settings that you saw on the generated? What are... I think that's technically what are... Anyways, I don't know. I'm just trying to catch up on stuff and get this stuff all ready. We went over this stuff on Saturday. I just didn't get it all put down into the lab. Let's go get our discussions done. So our discussions are gonna be, where are we at here? Nope. There we go. '22 through 23 of all right. So here's the questions, right? Here's the things that we might see here. So there's security services, right? And that's a section we're gonna read the security. Answering the following questions. How do these topics align So how do those questions or how do these topics align with what we've already talked about in the... We're up in Unit 9 now, so like all the different parts of the course that you've looked at. We're up on 1.3 now, so this is kind of an older reference. We're gonna probably use this as the other one because that's the other protocol that we discuss this week is the TLS, right? But anyways, okay. So, how are any of these terms or concepts new to you? That's good for that one. Review the TLS overview section, which is going to be pages 4 through 6, 4 through 7. 4 through 7 of this doc. What are the sub protocols? Of TLS. So what's TLS doing, right? And then how does TLS or how does TLS apply confidentiality? So all of these terms over here: confidentiality, integrity, authentication, and anti-replay. Confidentiality. Of course, the one time I actually want it to fucking spell something for me, it doesn't. Confidentiality, integrity, authentication. I mentioned this earlier, anti-replay. How do I ensure that even if somebody does get into the middle of this conversation, which they shouldn't be able to, but let's just say they could, they can't go back. You can't replay this authentication. Even if you captured all of these later, you couldn't replay it because the shared secret that's generated never passes the connection, never passes over the line, which is an interesting concept how they do that. They use the Shamir Revest, right? And yeah, look, this is the one I get again, man. This is the one that fucking had me rolling. People were sharing. There was like 10,000 fucking people had shared this thing on LinkedIn, and it showed that the server sends its private key over the network to the other device, and I'm just like, what fucking protocol are you guys reading? Like, what are you guys talking about? And this is a big one. This is like something go, like it's like a big one that people like all follow, and I'm like, that is not how that works. That's not even like, you can't go. I don't know. Whatever. I don't fucking care. People can do whatever they want. But that's, that's why one of the reasons I like engineering is it doesn't matter what your opinion is. Like, it either works or it doesn't. Like, I'll use my method and the documented method and the RFC to build it, and you guys will be over there doing whatever the fuck you're doing, and then the one that works is the one that's right? But which is one of the reasons why, again, I can't stand social media in general, where it's like, hey, this is how, it's the popularity that drives what's correct, and that's on the plus side, that's not how engineering will ever work. So, oh, thank God for that. But okay, I've got that. So I'm gonna add this. I'm gonna add these up to the Discord because I've been slacking pretty bad. Oh, this is Unit 9, by the way. So I gotta update Unit 9 and Unit 9. So I'm kind of slacking on this, but we had a really good conversation about it on Saturday. I just didn't have it all drawn up and all written out, so I'm gonna get it all on there. Dav over on the YouTube side, how's it going? We're not working super hard right now. We're just kind of, I'm trying to catch up on some stuff. Let's go grab this. Let's go grab our Discord. Come down here to course discussion. Say new post, and we'll drop this here, and this will be Unit 9. So security. Unit 9, discussion post 1, tag it to security, and then hit post, right? So boom, that one. I've owed the guys this since Saturday, right? I normally get them done early on Saturdays, but this weekend was just not great for this, for this other stuff. So all right, we'll get this up here, and this will be new post here. Discussion post 2. We'll tag it to security course. Boom. All right. So that's up. So now the guys can work on that. I'm not like a stickler for when things get turned in, so I'm not really a stickler for how long the things have been up there. But look, people are still discussing the other stuff, which is kind of good. Every time I see like the study groups, I see people go and add their topics and stuff. And again, if you guys want to jump in and do the courses or read through, all the stuff is free. Let me pull up the course for people that might be interested. LAC, this is our professional users group. This is the 16-week course right here. This is all completely free. The guys have done a really good job of putting this book together. That's right there. I'll link that to both sides. And then the security course, PSC, I think is the name of that one. And here's the intro, but the intro is never found. Here's the course syllabus. And if anybody wants that one, that one's there. You guys can jump in the courses anytime and just do the work and practice and study and, you know, whatever. But if you want to get the little certificates that we have, the ones that come from here, we've got, you know, you can go here and you could verify that, like, you were me and then that you had done the course. There's actually one of our guys, Treasure, he puts together... So he puts a little QR code on everybody's certificate, and then when you show somebody that QR code or you put it on a resume or whatever, if they look that up, it'll drop them right in here and it'll say your name and then that you passed the course or whatever, that you did our course. Yeah, it's pretty good. Yeah, he built all this stuff. He did a really good job. Here's more info about either of the courses. They're both free. We just run them out of our Discord, guys. You can go in there and just see what people are talking about and see what the kind of challenges are of the course, right? In fact, I think the study group's done, but one person's still hanging out down in there, right? So, I was saying this earlier. There's a lot of events. Every event is free in our Discord. We don't charge anybody anything. Just come and hang out. The goal of our group is to make you guys go from being amateurs in this space to being professionals. If you want to do this type of work professionally. Oh, hold on. I got a bunch of messages. Speaking of professional, I got a bunch of messages. I got to check them. Oh, jeez. All right. All right. All right. Cool. So, this is what we're working on right now. All right, so I have this. This is almost all done. I need to add some links here. The links will be these two links here, which are the NIST special publications. I'll just add those in because I think it's useful to have that all down here. And then the terminology for this week's thing. The terms are things like... let's say TLS, symmetric keys, asymmetric keys, non-repudiation. What other of the many things did we say? Anti-replay. Those were all concepts that we kind of touched on as we did this. Don't need any of that. Digging deeper. Finish reading about TLS in the publication and think about where you might. That's good, digging deeper. And then reflection questions. What were newer topics to you? Or alternatively, What was a new application of something you may had heard about? And then I said, what questions do you still have about this week, and what are you going to use in your current role? All right. I think that, let me see if I can call this one good. Still a mess. Definition. What? What? Oh, terms. Oh, like I'm thinking. Those things should have been up here. Oh no. The worst timeline. Alright, there we go. I need more things to throw up here. What are other concepts? What are some things in my, hold on, let's pull this up. Plain text. We had, oh, so obviously, ciphertext. Those could be two words. Yeah, I had mentioned the symmetric versus the asymmetric as I kind of drew this up earlier. Fingerprints. Fingerprints. We didn't use the passphrase, but you should still know what the passphrase is. Hey, thanks for the follows, guys. I see a few people followed. Hopefully this stuff's useful to you guys. I'm not being super engaged right now. I'm kind of head down on this thing that I'm building for the guys. I think that I can call the worksheet done. Let me look. Yeah. You guys got to understand, I'm overly critical of myself. Well, in general, I'm overly critical. I think that's what most people would criticize me about. But also, I'm very critical of my stuff. And I don't think my work here has been great. So, anyways, let's pull this open. File location. And we're going to say that the worksheet's done. So the worksheet goes typically right here. Where's it at? Prolog projects. That's typically where I throw this. Unit 9. Worksheet is done. Right? And then now I got to finish the lab up. The lab is, I just got to write up some questions for it. So let's do that real quick. All right, I'm closing that up. Not my best work, but I guess it'll do in a pinch. So here's the lab, certificates and keys. And shit. There's this. Let's go over here. Let's focus on what we're doing in this lab, and then I can ask the questions better over here. So these labs focus on certificates and keys, and securing systems and system communication. And then it's keys. We're going to flip that around because it's keys. All right, so there's that. There's that. And then all the rest of this is all right. Digging deeper is always its own challenge. And we can leave the digging deeper off for this one. Well, let's think about that. What kind of digging deeper labs? Okay, hold on. I got some digging deeper labs that we can do. Sometimes with the digging deeper sections, we do other people's labs because, why not? And let's do these two. So they're going to do certificate signing requests. It's weird. We want to restart the numbering over. That's wonderful. Can't I just start over? Really? Not gonna just let me. It used to be that you could just set the number. Yeah, set the number back to 1. All right. Control B. Oops. Control B. We don't want to be bolded. All right. Complete the following labs and see if they reinforce any of your understanding of certificates with the use of Kubernetes. All right, so here's the 2 labs. So manually signing a CSR, and then we're going to, I don't need that. I don't need the actual lab right now. And then via the API. All right, we'll bump out of there. All right. All right. Complete those. So that's digging deeper. Don't need that right now. All right. Let's go to our labs. Let's do our labs real quick. If anybody wants to do them with me, I guess I'll pin them for you guys, and then you can follow along if you want. The first one we're going to do is going to be the rsyslog one from the other day. I actually finished this one over the weekend. So if anybody wants to do this lab with me, here it is. Link this for you guys. Yeah, here's what our courses are about, by the way, in case anybody's wondering. Here's what the actual course summary is, and we run them like a real course, right? Like you might run into in a real college. All right, so I'm going to do my lab. So set up TLS and configure rsyslog on 6514/TCP4. That's control plane node. So your team has determined that they need to centralize logging in the environment, the security STIG guide requirement for government systems. Your previous setup of rsyslog that you did in one of our earlier labs did not encrypt the traffic. It just sent it over UDP, which is fine. It depends. It depends on the security posture of your organization. There's going to be a little more overhead on the systems with this, but this is a more secure way to do communication. We're going to throw things over TLS. So you know that TLS can be done, but your organization doesn't have a PKI. That's a Ooh, I should have thrown that in there. PKI, public key infrastructure, right? Also, well, there's another thing I want the guys to study, which is X509, but maybe I'll just touch it in the discussion. But anyways, all right. So you know TLS can be set up for your organization, but you don't have PKI infrastructure. So set up certificates. You're going to do it all manually. You're going to build everything manually, and then you're going to set up rsyslog on control plane to capture, and then we're going to verify that we're listening on 6514. So we're going to do all of the setup stuff here. So let's install the packages that we need on both servers. Then we're going to install the package that we need on the other server. Oh, shit. While that's going, we'll take a break real quick. I'll be right back. Take a little break. Go wander around for a minute. I've been talking for 2 straight hours, so. And I did a college class earlier, so. Grab some water and walk it out real quick. I'll be right back. That thing's gonna take a minute to pull info. So you guys hang out, and Robodom's in charge, so I'll get back. All right, I'm back. Let's run this command. Make sure that's installed over there too. All right, turn my camera back on. All right, drink some water. Anybody that got here late, we're doing some labs, making sure that my lab stuff aligns with what I have written up over here for the guys. So, install those packages. Back this out a little bit. Move this over so we got a little more room. Very good. So, once that's done, we're going to make a certificate. We're going to go into a certificate directory, and then we're going to start generating. So we're being our own certificate authority here. The best way to describe what we're doing, I guess I'll make the guys do it. I love this book for this. That's funny. That's in the wrong font. We need to go back to Calibri body. And then we'll say, fuck it, whatever. Pages 41, 42. So let's go here, 42. So 41 through 47. Yeah, 40. Yeah, really 48. Does the diagram on 44 U4 So does that diagram make sense to you from the context of what you did in this lab, right? You set up a root certificate authority and you started signing certs out of it for your different stuff. And that was the proof of trust for the whole organization. And you're generating and signing all your certs from that. That's what we're doing in this lab, all right? So first thing we're going to do, we're going to move over there and we're going to generate that CA key.pem, right? So we're going to generate that one, right? And then we're going to sign that. From that, we're going to sign, and we're just going to say, we can say US. We can, really doesn't matter what we do except ProLug is going to be our professional Linux users group, is going to be everything, and we're going to keep everything else default. And the activation time, we're going to make 90 days. So the certificate will expire in 90 days. Most people, if they're signing their own stuff, they make that 10 years. But I'm going to tell you, we're doing this by hand. And most of this stuff is much easier with tools like Vault or some type of Vault is a good one from HashiCorp, or some of these other ones that can be our certificate authorities and they can sign all of our stuff for us. But let's we don't need to do any of this stuff. We can hit yes on some of these, but it's really not that big of a deal for the lab, and it doesn't matter. These things would probably matter more if we were running this for real. Now here's the information we want, and we're going to hit yes. If you don't hit yes there, it won't generate this signed PEM file, right? So our out file ca.pem. Now if we just stop for a second and ls-l, we'll see that the original key is private. You should never share that with anybody. But the ca.pem is the signed, we just generated our self-signed cert, and then that one can technically be used wherever, right? But we're going to come over here, and now we're going to generate a new private key for the control plane node. So the control plane node is going to get his key. And then we're going to generate a certificate request for control plane. And we're going to go ahead and accept all defaults on this one, all the way down the line. There's a bunch of stuff that may matter to you, but doesn't really matter to us right now. And then we're going to sign a certificate. We're going to sign a certificate request from the CA for this node. This is where this actually matters to really everything. So now we're going to make this expire in 60 days. So mine can't exceed the CA, but I could try if I want, and it won't. So I'm going to say no. It's not okay to proceed. Let's go 60 days. And then we'll honor all extensions if they were there. We're not going to work. Oh, man. I needed to make sure that I had the DNS name, so I wasn't paying attention. So I'm going to start this over, right? And we'll say 60. And then we're going to come down here and enter DNS name. We can make that control plane. And if there's additional DNS name, we can. If we had a URI, like a full HTTPS, some web server, we could put that there. If we had an IP address we wanted to use for this in the certificate, we could. We're not going to use any of that as long as we have the DNS name right. Oh. If you get to the end and you don't hit yes, it doesn't generate. Got to do the whole thing again. Yeah, it's annoying, I know. 60. TLS web cert, domain name, control plane. If that's not spelled right, this won't work. Get all the way to the end. Motherfucker. All right, I'm not doing it on purpose, guys. I really am, I guess, this tired. DNS control plane. Yes. All right. ls-l. Whoops. ls-l. We'll see all of those generated, and then now we can validate any information we want. We can look in that one that we just generated, our cert.pem, and that was the most recent one that was generated, and that is for control plane right there, right? We see the DNS name of control plane in there, so that's good. We're going to change that. We're going to change the ownership of the key.pem so that it can be read by the system. We need to do that. And all we did to make that as secure as possible still when we do an ls-l is that one can be readable by the syslog group, but not readable by anybody else. So this one's still pretty locked down, even though it's 640. It's only root and then syslog, which is only running our syslog on our system, right? So then we're going to copy over the correct certificate .pem that we need over on the CA.pem that can be read is being copied over to node 01. And then we're going to go set some configurations up for our syslog. Now, if any of this stuff is like, oh, this is kind of moving fast, we already have a log on our syslog, a lab on our syslog. And if you go do that lab, you do a lot of this stuff, but without all the encryption part of it, right? So now we're going to set this all up and use the custom TLS config that I have here for you. What I want you guys to pay attention to is what we're doing. So we've got a global configuration, and we're pointing our CA file, our certificate authority, to that original ca.pem, and then the stream driver cert file, cert.pem, and then the key file to key.pem. We're going to load for TCP, that's IMTCP, the GTLS package that we installed at the beginning. And then we're going to say listen on port 6514. Those are the important parts of this. Escape :WQ. Well, they're all important. It'll break if you don't have them all. But we're going to save that. We're going to restart our syslog. We're going to go look at it and see that it's running. It's not busted. And if we listen, if we check our listeners on SS to see all of the listening ports, we see 6514 being listened to for IPv4 any and IPv6 any. So we're listening on both. Now, we're only going to accept encrypted traffic being sent to control plane, but we'll see that here from the second part. So now we're going to go, so far you've enabled our syslog collection on control plane for TCP port 6514. Now you must configure node 01 server to securely send logs over to the correct port. So we're going to go over SSH to node 01, and we're going to set up this custom TLS client setup at the bottom of that file. So that's VI our etc syslog. I hit Shift G typically to go to the bottom, O, and then Control Shift V to paste. And we will paste in, here's our user local share CA certificate ca.pem. That is the certificate signed key, right? And then we're going to say action is send to the target control plane on 6514, and it's going to validate that it's talking to control plane as it communicates over there. And here is every log being sent to control plane on 6514. There we go. All right. So escape colon WQ. And we're going to restart our syslog. We're going to add a user, some user. That's just some generic thing that's going to drop down in the logs over here. In fact, if you grep-r some user from var log, you're going to see that some user was put in var log auth log, right? Now, if you exit back over and grep that same thing over here, you're going to see that it made it into control planes logs, var log auth log, but from node 01. So node 01, there you go, boom. All right, and where did the logs land for that user that was created? It's logged in the exact same place over there. Okay. Well, 2FA, I mean, you know, people getting banned on Twitch, that doesn't happen accidentally. I can tell you that for sure. And I'm okay with people hanging out. I want people to do this stuff professionally. So I just tell people, you know, try to, I don't know. I guess most people I would just say try to read the room. If you got banned, I can assure you it was for real. And it probably, actually, I think if it's the case I'm thinking of, because only a few people have ever been banned. I'm pretty sure one of my mods did that. So, but I don't know. Anyway, so look at you learning Linux security. You set up custom logging, you were able to see the data flow from node 01 into control plane for centralized logging with TLS. Then you can go look at why we want to do this. This is very important. In the MITRE ATT&CK framework, one of the things people want to do is always delete or modify artifacts. Remember, our logging is always supposed to be immutable? Always. Well, if people can modify or delete shit, well, that's terrible. But what if I'm sending stuff off in real time? What if I send stuff off in real time as fast as I can, and in that sending stuff off as fast as I can, you don't have time to delete stuff? What if even you logging into my system and gaining access, which is terrible, I'm at least logging that before you delete everything? That's what we want to do, right? That's what we want to be able to do. So that's the part of the MITRE ATT&CK kill chain or MITRE ATT&CK framework that's very, very big, very popular. And then also, here's the rsyslog tutorial that this came from. But obviously, this is just a generic one, and mine is set specifically for those two nodes. This will give you some of the background of what you just did, if you want to read a little bit more about it. So that's the log, or that's the lab. Over here it says, when you finish the lab, review the following items. And let's come over here and say, what, let's go. So I think that's good for that lab, because that lab's pretty complex. So we'll call that lab good, and we'll call that section of the lab good. And then let's go to I'm going to say a digging deeper challenge. Whoops. I do not want, oh, hold on. Let's get rid of all this crap. Whatever just happened, get out of here. Okay. Let's say this right here is read the rest of this, and how does that align with your understanding of zero trust? If you haven't read about zero trust, start here. And I'll give the zero trust NIST 800-207. All right. So I think this lab's this is already gonna be a lot. And here's the thing about the security engineering course. I'm not trying to make it a lot for the sake of a lot. I want you guys to know, I want you guys to be exposed to a lot of this stuff, so that the stuff that's useful and the stuff that is actually needed, you can go back and maybe reference or filter through later. But at a high level, I want you guys to understand kind of what's going on with the system. It's not just about busy work, right? Even though this is kind of probably the shortest lab doc right here. In the big scheme of things, it's probably the shortest one. But I want you guys to feel like if somebody asks me a question about certificates, I understand why we use certificates, and I don't have to bow out of the conversation because I don't know how to generate them, or I don't know what they're doing, or I don't know what a certificate authority is because I've never heard of it, right? I want you guys to be familiar with those kind of things and where we use them. So what is the significance of the permission settings? I think that's, yeah, I think that's good. All right, we're gonna call the lab good then too. So I'm gonna file, save this down as a PDF because I always give it to the guys as PDFs, and that's all that. All right, so now the last thing I need to do then is clean this all up. I think Solving the Bottom Turtle is one of the best books. One of the members of our community, Taniwa, who shows up every now and then, they were involved with writing this, so they're part of SANS. They work with them and do speaking with them. So, all right, let's let me drop that up in the Discord. Hold on. So we've got this and certificate. Oh Jesus, damn it! All the things that just happened were not what I wanted to have happen right there. So, all right, let's drop this up here. Lab is complete. Now I have to set up and record the full presentation. All right. And then, as you guys saw, I was working on the presentation earlier, and I fucking... oh, I did not save it. I lost like probably over an hour worth of work in that thing. That's super annoying. All right. But anyway, so we've got this stuff. Yeah. I want you guys to, keep working on this stuff. We have all the ability. I could turn on all the stuff for like our normal, just kind of hanging out and talking about stuff. But what I'll probably do is, I need to pull that out. What I could do for fun, something I haven't done in a little while, is I could just kind of brain dump on you guys some of the security stuff that's unrelated to the actual security course. Just some stuff that I have in general hanging out there. This is one. I'll make this a little bigger. Hold on. This will be fun. I'll do the security course. This other topic down here too. But this right here, I was mentioning this earlier. If you've never seen a simple communication model, or what I use as a simple communication model, this is it right here. This is a 5-part model that must exist for communication to occur. It's a sender, a receiver, a message, a medium, and noise. A sender always encodes a message. If we encode something on one side, we must decode it on the other. If we encrypt something on one side, we must decrypt it on the other. If we compress something on one side, we must decompress it on the other. We must use the same thing on either side. When I tell this to my college students, it's actually funny. I always try to make this like make sense. Like, if I'm encoding a message right now to you guys, right? I'm doing it in the English language. I'm speaking somewhere probably between 120 and 160 words a minute, if I had to guess. Maybe I'm pushing about 180 when I really get going, but I'm not going faster than like some people can type. Some people can keep up with it. Obviously, my little closed captioning can, but that's automatic. But some people can about keep up with a person, so that's pushing like 140-ish, And if the sender, which typically when we do this kind of stuff, it's useful to note the way that we denote this as engineers. So this is always, the sender is always TX, I don't know what I'm thinking. And the receiver is always RX, so you're receiving. And those will be common things that you'll see as engineers in your career, right? The sending side and the receiving side of some communication media, right? This is the medium right here, which is the singular form of the word media, right? Media is the plural of medium. So here's our medium. Our medium can be open air. It can be copper. It can be fiber. Those are the main types of things that are used as media for sending things. Then within those media, there are standards. And as long as we adhere to the standards of how we encode and place things on those lines, we will also be able to then deal with all of the effects of that. So like, let's say that the medium I was using was a unshielded twisted pair. And that unshielded twisted pair was what we call like a Cat5 cable. And that Cat5 cable has 4 pairs of copper wires that are twisted at varying numbers of twists down 100 meters of the cable, and the 100 meters of that unshielded twisted pair are the maximum length that we could go before the attenuation of a signal down it. Whatever we put in on one side, the attenuation down on the other side is going to be bad after 100 meters. That we would deal with what's called signal to noise ratio, where the signal that was coming out, the message, has weakened so that the SNR, the signal to noise ratio, is too high for the far end to be able to decode, right? And all of these things that I'm talking about at a like very high level as an engineer, we could go and we can dig in and we could say, okay, you mentioned 100 meters, but is it really 100 meters? That 100 meters of cable that I'm allowed, that includes on one side like a patch panel, and on the other side like your final hop. I guess you would call it like it's patch panel on the IDF, and then over on the other side, I guess it would be just the your network cable, I guess. And then in between, we call it like a horizontal cable, and we're only allowed like 90 meters on that in most buildings, right? Now, that's if it's copper. You can go fiber and then go much further, but you could also technically still go over what's it called, coax, but most people aren't using coax anymore. You probably have coax maybe coming into your house if you're not all fiber. I still have coax coming into my house actually, but there's all that kind of stuff. Control byte with Prime.
Your kernel version is adequate for now.
It's funny you say that. Rocky 10 was just released, and I'm probably going to get some Rocky 10 in the lab. I need to, so hold on, we'll back up real quick. So I was just brain dumping on you guys. This is our connection into like the home lab. And some of you guys that have been using the lab know that when you jump in through the Bastion node and you hit the Rocky or the Hammer servers, my process isn't great for that. Like, you come in as an admin as Streamer 1 or MC Hammer, and you get dropped into a jail, and then you pick a server, and if the server is being used by somebody or the server's down, you just get kicked out, and then you got to go back in. My process currently is not great. So I'm going to rebuild the Bastion. And I'm going to rebuild how I do the Bastion to do some of these other checks that we have in place from... Well, there's all kinds of checks that I want to do. But really what I might be doing too with this is we're going to keep a smaller amount of servers ready. Because in the home lab, I have a tremendous amount of, I've got 19 Rocky servers, but our capacity, I'd say we're very rarely over like 1 or 2 people in there. And then in our Hammer servers, it's very similar as well. And you might say, Scott, could you track exactly how many people? Yeah, we actually do track exactly how many people are in there. I'd have to go write up some more process, but like log, in our logs and apps, we can see here failed, but I could also go like Hammer, and I could see, I should be, hold on, let's just go here. And here's all logins, right? Logs and apps. Oh, I might not have any Hammer. Let's see if Rocky. No? That's wild. There's our Rocky stuff. Yeah, it doesn't look like anybody's logged into any of these in the last 6 hours. So in the last 6 hours, we haven't had anybody log into anything. But I need to write some stuff up to make this stuff a little better. But anyway, some of you guys have seen like we have a pretty good amount of monitoring going in like the home lab, right? Where's Ranger Cam? Well, we got Ranger Cam. Security stuff, right? How's our lab? And I can see how many users are in general, but this is a much more generic view of just what's coming in through my my Bastion node. So I'll probably I gotta rewrite and update a bunch of the stuff in general, but where I'm going with that is if I make this more efficient. So if I'm more efficient in how you guys log in to the back end nodes, then I don't need to have nearly as many nodes up. Like I have all these nodes because it's just like a bunch of space because I thought we'd have a lot of people hammering them. But since I don't have that, I can move these down to only like maybe Rocky 1 through 5 and MC Hammer, or the Hammer 1 through 5. And then that opens us up for a lot more lab activities that we can do of other types and still have the first 2 courses running for people, if that makes sense. So the courses can keep running, and then you guys could be going on to other things. Like I've had a lot of people ask me about werewolf, doing a werewolf, show you guys how my lab works. Because if you guys have ever seen my lab, I can just reboot any of these boxes and they come up stateless nodes. They just come up over and over again. And I want you guys to understand that. And also, I'm seeing werewolf getting deployed everywhere in government systems. So it's really a big thing. But anyway, so back to the simple communication model. One of the things I'm going to do with this, and this is going to be my theme for week 10 of the security course, is I'm going to tie everything back that we've done to something simple like this. Like, okay, so you want to remotely get into systems. If you want to, allow users to come in, we have to authenticate the user is who they say they are. Then we need to give them certain accesses. Then we need to, so that's authorization of the, so we authenticate you are who you say you are. Then we authorize you to do certain things. And then we audit you, right? Those are the AAAs. We audit you for what you're doing. And then we go on about our day or whatever. So, and I'm going to tie a lot of the stuff that we did in the course, the security engineering. I don't even know where it went. I thought it was one of my windows, but the security engineering course, I want to tie it back into maybe not directly this, but the components of this that people are going to run into and find interesting. So, all right, let's go brain dump a little bit. I haven't brain dumped on you guys in a while. So let's go talk about compute and data security. This is an old topic that I talked on, and I'll just brain dump on it. So here's what we're going to do. We're going to talk we'll go as basic as we need to. Protecting data security. We'll talk about the CIA model. Most of you have probably heard of that. Then we'll talk about defense in depth, which if you haven't heard about that, that's what we call layered security, right? We'll talk about how we access the cloud and what it means that everything's an API. Then we'll talk about data at rest, data at motion, data in use. What does that mean? And how do we protect data that are part of our company? Compute security is protecting the compute type resources. So I am very much focused on the system. Like I'm a system engineer, a Linux engineer, a high performance compute, but I care about what's happening in the system. In fact, that 10-week course that we're doing and we're almost done with is heavily focused on securing the compute system, right? That's what we've mostly been working on. And then we talk about symmetric encryption and asymmetric encryption and how that works. And then we talk about SSL and TLS. What does it mean to be transport layer security? What are they and what is PKI? And then we talk about troubleshooting cloud security problems. And I have no idea what that is, but I see 2 like Linux words in that. It's pretty funny. Hold on. Let me I'll pull this up real quick if you guys haven't seen this. Hold on. I don't know any of what's happening here. I don't. I see this word that I know and this word that I know, and then that looks like a house, and that looks like a house, and that looks like a house. Probably do some kind of like decryption or something. But again, that's probably a message saying, Scott, I get it. If I encode with something you can't understand, the receiver can't understand it, and that's a perfect example. Thank you for that. That's a perfect example of somebody encoding a message in a way that I can't understand. So then when I receive it, I just go, big shrug. I don't know what it is. So that's a perfect example of that. I appreciate that. All right. So anyway, so let's talk about this. So protecting data security. So confidentiality, integrity, and availability. Most of you guys have seen this. This is like one of the oldest security things around. Yeah, Robedom, I don't know what that was. I thought it was funny, but I don't know what it was. Confidentiality is data can only be viewed as by the person who's supposed to see it. The person or people. And if we want to get in the business of having confidential data in our organization, which we do, we need to be in the business of data labeling. And then if we're going to data label, right, things in our organization, we're going to label something that's going on, then we need to probably have people that are assigned as data owners, people who can set those labels and can give permissions to read things. And then we're going to have people that are like me, data custodians, who I don't own the data, but I'm very, very instrumental as root in a Linux system in keeping that data secured, so only the people who can see it do. So confidentiality is this very simple concept that very quickly starts to be like, well, who can see the data? Well, I don't even know because everybody has access. Well, that's a problem. So then we start to talk about, well, is the data labeled properly, right? And one of the simplest ways to do this is access control lists. Then we get more and more complex access control lists like SE Linux. Then we start to talk about actual like labeling and metadata tagging that we can add additionally on top of systems. So confidentiality has a lot of components of access, right? The main way that we keep confidentiality of data is through encryption. We do some type of encryption of data as the data are moving, encrypted. As the data are sitting at rest, encrypted, right? And then even if you pick up that data, it's like this, you can't use it. You have to have some way to decrypt it so that it's useful again, right? Integrity is the data are not modified from the time that they're put wherever they're put until they get picked back up again. And when I say that they are not changed, I mean not just by some person, either a malicious or non-malicious process, but also who can change the data, who has access to change the data. That's all about integrity. And then another one is, does entropy or the passage of time also affect your data, right? What did I miss? Government's been tossing around zero trust a lot more these days, especially with cloud architecture. Yeah, Control Byte, I don't know if you just dropped in. Did you know that I just linked the zero trust a few minutes ago? I don't know if you saw that. I was just linking zero trust SP8 NIST SP800-207. Is that right? Let's see if my brain's working today. My brain's never working, but let's see if it's working today. Yeah, 207, zero trust. Boom. Got one right. Yeah, I was just talking about zero trust architecture and telling people to go read it. So I dropped it in. I actually had it dropped in right at the end of the lab. So for digging deeper challenges, which are not required for the initial, for the lab, all you got to do is go complete the 2 labs. But if you want to dig deeper, go do these other labs on how Kubernetes does some of that certificate signing, and then also read about solving the bottom turtle and publication. So this right here is like, the reason this is digging deeper is this is like a few hundred pages of reading. I'm not actually making anybody do that for the course, but if you wanted to go read about it more, I think that would be something that would be valuable for people. So anyways, yeah, zero trust architecture is huge right now. Control Byte, 100%. So integrity is the data are not modified between the time that you put them down and you pick them up. Whether that's because, like one that's kind of big for this is the data the same 1 year later or 1 year later after it was last touched? If I go put data on a tape and then that tape degrades over the course of 3 years and I go to read it off again and I can't get at the data, the data are gone. Does it matter if I have somebody to yell at or some neck to wring, or if the guy who originally set it up got fired 3 years ago or retired? Does that matter? No, it's still my system and my data integrity that's now been compromised. So it's very important to understand that integrity doesn't just have to do with malicious things and malicious changing. There's an old, you want a fun one, go look this up. This thing all things devours, birds, beasts, trees, flowers, gnaws on iron, grinds steel, grinds hard stones to meal, buries kings and ruins towns and beats high mountains down. I don't know the whole thing, but I used to know it when I was younger. Some of you might know what that is. Does anybody know what that is? But yeah, the integrity of a system. This one thing beats all things down. Yep. And that's from an old J.R.R. Tolkien book that I loved as a kid. There's a live subtitle. Yeah. So, by the way, over on the YouTube side, it's like, I think, by the way, I generate my own. These are my own closed captions. But then I think YouTube in the future, I've been told this anyways, if anybody cares. I've been told on the YouTube side that my languages, like the language I'm speaking right now, is going to be translated into like 10 different languages. YouTube asked me, I'm sure they asked all their partners, but I don't know. They said, hey, Scott, can we translate your stuff into all these other languages? I was like, hell yeah, you can translate my stuff into all these other languages. So my understanding is sometime this summer, I don't know exactly when it's going to start, you guys will be seeing my closed caption down there, and then you can change me to be in like, I think it's like German, Japanese. There's a bunch of languages, but they're like very like large languages. So anyways, yeah. So hopefully that works. Ooh, my wife brought me. Thank you, wifey. My wife brought me one of these. Guys, I have to get off of here soon because now I got to munch on this. But that's good stuff. All right, we'll finish this last one. Availability. Data are accessible to the intended recipient when needed, meaning the sender is accountable for successful delivery of the data. That's a TCP concept, not a UDP concept. And then, is the system available at all the times that it should be? We tend to use, for high availability and uptime, we use what are called like the nines models. And you guys will hear people say, oh, that's a 2.9 system. That's 99% of the time. Or that's a 4.9 system. That's 99.99% of the time. And these are all very well documented. So you can come over here and you can go to like HA Wikipedia, not HA, but HA, which is high availability. And, oh, well, maybe down here, we'll go to high availability. And you can see all of these. So here's like a 3.9 system. In the course of 1 year, the downtime that was unscheduled per year on a 3.9 system is only 8.77 hours. That's one working day of downtime for a system. A 4.9 system is only 52 minutes of unscheduled downtime. That's wildly difficult to achieve those. In fact, every time you go for another 9, you scale up by 1 0 on the end of cost. So if you had like a 4.9 system that was $10 million, to get to 5.9s, you are probably looking at a $100 million system now. And these are the types of systems that I build for the government, these huge systems that have these high availability numbers. But I was telling you guys the other day, we don't shoot for these. This isn't what a lot of government projects shoot for. We shoot for 98.5. So somewhere in between here. So 98.5, but with 2 systems, is much cheaper than trying to shoot for like a 99.99, which is 4.9s, very low downtime. But that sliding window of about 5 days of downtime. So 5 days out of 365 and 5 days out of 365, the sliding window chance of those overlapping, extremely low. And if you go to a third system, which is still only the cost of about a 98.5 system, which is lower than one of these systems even, you even lower that further, right? So anyways, we talked about all that stuff, and I do have to get off here, so I don't have too much more to go. But I have other days. I was just going to sit here and brain dump on you guys for a while with some of this stuff. But this talk and all this stuff is up in the Discord, so if any of you guys need it, go hop up there and look at that kind of stuff. RoboDom's been dropping the Discord for you guys. It's completely free. We just hang out in there. We're almost up to 4,000 users. So, yeah, feel free to come by. And also, yeah, anybody that, even if you're hanging out, listening in a different language, hopefully the subtitles are useful to you guys. So, all right, I got to drop off of here. Let me go drop on my little end of stream thing here. I appreciate everybody coming by. We got a lot of stuff done, and hopefully this stuff, again, helps you guys out. A lot of this stuff that I just put together is up in the Discord, so you guys can work in there with the study groups and all that kind of stuff too. All right, you know what? We'll raid somebody on the Twitch side. Let's see if we can find somebody to raid real quick. Following, let's go to, who's on? Oh, Midnight Simon's on. We're raiding Midnight Simon. He's one of my favorites. So I will see some of you guys later on this week. I'll try to be getting in here and streaming more because I'm not as busy as I was. It looks like he's trying to raid somebody. So hold on, we're raiding him before he can raid us. See if I can get him on a raid real quick. All right, I'll talk to you guys